Y'all, welcome back to the nest, and let's get rocking and rolling with some code. Come on in.
Going to be working on activity 1.3 that is entitled How to Do It. And this is going to be the first time that we are dealing with the microbit website, where we are going to be using an emulator. So there are several things that you are going to need. They're listed here, but also you are going to need your digital notebook that looks like this. And when you go to the slides that are dealing with this section, it starts with slide number 39, and it is the next 8 or 10 that are right after that. You also are going to have to go to your Project Lead the Way website and use the same credentials that we've used every day that are listed on the second or third page of your digital notebook. When you log in, you're going to go to your courses. You only have the option for CSIM, so you are going to click into that one. And then, like I said, we are looking for activity 1.3. So when you click into lesson 1, over here on the left-hand side, you can go to activity 1.3 a little bit easier. Looks like that right there. And so then this has absolutely everything you will need. It has screenshots of things that will help you navigate through if you get lost. It also has videos embedded, and it also has all of those key terms that we are going to need. Also, anything else that you need to link out to, it has it listed right there. And it also has these resources here that you can download. So I would go ahead now and open up the microbit website, that is makecode.microbit.org. And I would also go ahead and open up draw.io, because we will be making a flowchart. And I would go ahead and press the thing to open up a new diagram before I even get rocking and rolling.
Thanks for
All right, so now that we've got that, let's go and take a look at our digital notebook. I've gone in and added a few things on mine. All right, so the very first thing here has all of our steps, but before we even get to that, let's look at our essential questions. And the first thing says, how do you express yourself and creativity through computer science? Well, I mean, you can pretty much use anything and everything you can, or that you can think about, to express yourself, such as when you guys make your flowcharts, you are able to use your own colors. You're able to take and customize this notebook to add anything in. So I would go with something like that. Second one says, how can algorithmic thinking skills be used across multiple disciplines? Well, we've already talked, such as in your science classes, when you guys do labs in there, you go through the same exact process. And even thinking about your daily activities in your regular lives, like brushing your teeth, getting up, taking the bus, whether or not to do your homework, all of those things are algorithmic thinking. And then the last one there says, how can computer programs solve problems? The entire reason that we create computer programs and code apps and things like that are to solve some type of problem. That doesn't necessarily mean it is a bad problem, but it is just a problem in general, such as if we want something to blink lights upon the screen, like we're going to in this program, that is in essence a problem that we are solving. All right, so we are not going to be using the microbit controllers. We are going to be using just the emulator that is in the microbit website. So the next thing is for you to open up the microbit website. All right, so now we are going to go into the Project Lead the Way website. All right, I'm going to big screen this so that you guys can see it a little bit better along with me. All right, so now the first part of this assignment, before we actually really get rocking with creating some code and some output, we have a scavenger hunt to see what all exists in that microbit website. All right, so we have here that we're talking about algorithms. We're going to put them into a program, and this is the first program that we're going to be building within that microbit make code website. We are going to be, for this entire course, we are going to be programming an LED panel, which, if you are not already familiar, that stands for light emitting diode, on our microbit controller. And then we also are going to have extra things that we would plug into that microbit as well. We are using what is called block-based programming, which is the puzzle piece-like pieces that we are going to be adding into the code. It is a kind of the first step of coding. and then we graduate up to more big boy coding. If you've ever heard of Python or C++ or Java or any of that, that is the next step after we get used to and familiar with block-based coding. All right, so now we have our instructions here that we are going to go to the microbit website and we're going to start poking around. All right, so before we even do that, it has a bunch of questions in our digital notebook about where can we find certain things. So exploring MakeCode steps 1 through 8. So I'm looking at slide 40, 41, and 42. Okay, so 40, 41, and 42. Those are all going to be things that we are trying to find, such as number 1 says, in which drawer would you find a block that would allow you to subtract? All right, so that means that we're trying to find where that lives. And in your Project Lead the Way website, a lot of these give you really, really big helpers, such as if you need a hint, it's going to try to help you to find those answers. But when you go in to the microbit website, that is, let's go to the microbit website. It is makecode.microbit. We're going to create a new project, and we're going to be looking for the items that are in that scavenger hunt on those 3 slides. So the first one is saying, where would you be able to find something that subtracts? If you can't find your answer there in the list of everything that you have in the drawers, you could go up to the search function and start typing it in and kind of match the color up. But I think it's fairly simple for you to see that something like subtract is going to be found down where it says math. But if you were not able to find it that easily, you would be able to use that search function. And you'll also be able to use that when we are writing code. So once you figure out each one of those answers, I want you to go back to your digital notebook on page 40, 41, and 42. And that is where you will be typing in your answers. And then you are done with that first section and you can move forward. For this second section, we are now going to be creating a flowchart for our program of what we are wanting our microbit to do. And remember, your microbit is just a bunch of LED flashlights. So we get to kind of write the code the way that we want to. And what's awesome about that is that we have a lot of freedom. Just for our example for today, I'm going to give you guys what I want the program to look like, but then here forward, you'll have a lot of choices. So when we create this flowchart in draw.io, remember that we have to use these same symbols, however you guys can customize the colors. All right, so I'm just going to go over and grab the flowchart idea or what I want you to generally make it look like, and then we will go into draw.io and draw that. So over there on the left, that's what we're going to look like or make it look like. That is not meaning that you have to do those exact same colors. In fact, I highly suggest you don't, because being the same as someone else is boring. All right, now we are going into draw.io, and I would go back and I would change this to have the name, well, your name first of all, and then the name of the project, which is Activity 1.3. And then we're just going to go on this left-hand side over here and start grabbing down the shapes that we need, and then changing the words. So you see you're going to need a start and a stop that are going to be that oval shape. And then you're going to need a conditional statement that is going to be that diamond shape. And then you are going to need 1, 2, 3, 4 commands. And those are going to be the rectangles. And we will attach all of these and put the words in just a moment. All right, so I'm going to go here and add in the word start, and to the other one, and go ahead and add in the end or stop. All right, so our conditional statement, this is going to be our yes or no question that we are going to ask it or have the program ask itself. And just for our example, let's say, what if we ask it to repeat it 5 times? So our question would have to be reworded to be something that could be answered as a yes or no, like, have I repeated this program 5 times? If the answer is yes, it would stop. If the answer is no, it would have to go through a series of steps. All right, I'm just going to go in and add a color for these blocks here. So if our answer is yes, then we would connect this one directly over to our stop. And then if our answer is no, we would move forward to the commands. All right, so now let's start connecting our commands. All right, so now we are going to start adding in our commands and then linking them together. And these should flow in one direction because it should immediately do the next item without doing anything else. So when you go back and you start debugging your program to check and make sure everything is working correctly, that is one thing you can check. Make sure that everything is flowing in one direction. All right, now we're going to add in our second command and then link it to our third one. And then link it to our fourth one, or our last one in this case. Now, when we start getting further into this class, you will notice that these flowcharts will get more and more complicated. So you really need to pay attention very intensely as we do these very, very simple ones, because they do get harder with every single project. They get more complicated and more difficult. All right, let's go back and add those words in of the yes and the no. And then we are almost done. We just need to go in and give these a color. Last thing I will say is for us to go in and add a text box on the actual flowchart that includes what the flowchart name is. And the reason for that is because I want you to be able to find this later. So if we've got a cache of all of these saved into our Google Drive, if the actual flowchart itself has the name on it, then it will be a little bit more recognizable. All right, so all I'm doing right here is I am connecting the last command back up to our conditional statement. And the reason I'm doing that is that after it has done that fourth command, it needs to go back and the program needs to ask itself the same question. So it would be the exact same thing if we were going to a red light, that we would have a conditional statement of what if the light is green, then we would go forward, right? Well, what if the light is red? We would stop and then we would wait a couple of seconds and then we would ask ourselves the question again of what if, the light is still red? And we would follow that exact same thing in a loop until our answer is different. All right, so I would go back in and give it a name. Obviously putting your name, not my name. And then we are going to export it. Now, when you export, you have the option to export it to your Google Drive. If you do that, I would go ahead and save it to your Google Drive folder for this class. If you want to just download it to the hard drive of your computer, that's fine. I would just be very, very careful if you were working in a Chromebook when you were doing this, because your Chromebooks don't like to save files for longer than just a hot second. But nonetheless, it will be saved in this draw.io program. You may even want to create a subfolder within your Google Drive folder for this class for your flowcharts. I think that would be a really good idea. And then once we download this, we are then going to take it and insert it into our notebook. And the page that this is going to go on is going to be page 44, or slide number 44.
Today we're going to go ahead and take a look at Activity 1.3, Programming the Blink. Now we're going to go ahead and use this flowchart that is already kind of done for us to create our first program in our MakeCode software. Here we'll get a chance to see how some of the blocks function and how it actually works with our emulator. So as far as our flowchart goes, we've created this flowchart that's basically going to get our first initial to blink on and off for 5 times. Now we can look at some of the commands that we have in that flowchart. We have our beginning and our ending point, which is our start and end blocks. And from there, we're going to go ahead and look at a repeat loop, which we're going to set to repeat 5 times. Within that repeat loop, what we want to actually have happen is we want our first initial to show up on the screen for 500 milliseconds or a half a second, and then disappear by clearing the screen. And we're going to wait another 500 milliseconds and then repeat that same procedure 5 times. So in order to do this, we're going to go to our makecode.microbit.org. And once we're in there, we're going to go ahead and select New Project. Now, once we select our new project, it's going to go ahead and ask us to go ahead and enter our name. So we're just going to go ahead and give this a title, and we're going to call this Programming the Blink. And then I'm going to put an underscore and my last name. Once you do that, go ahead and select Create. So that's going to give your program a title. It's going to hopefully be easier for you to find it later on. Now that we're in our MakeCode environment, we have to look at what we want to use to actually start our program. So these blocks up here are what we call event handlers. And event handlers are something that triggers an event to take place. So the 2 event handlers that are given to us to start off with is an onStart and a forever. So when we take a look at our onStart, what we can do is just kind of leave that mouse hover over there, and it's going to give us a little description of what that event handler is actually going to do. So in this case, our onStart event handler is going to run the code when the program starts. So it's not something that's going to keep repeating. It's just going to go ahead and run whatever is in that block once we initialize the program. Your forever block, this is going to repeat the code forever and ever in the background. So on each iteration, it allows the code to run. So this is something if we want it to keep running over and over and over again. So we need to decide which of these 2 event handlers do we want to use. If we take a look at our flowchart, you're going to notice that our event that we're starting with is a start. And because we want something to repeat 5 times, we will not be able to use that forever block. If we were to use that forever block, basically what would happen is that our code would basically run 5 times, and then it would repeat that same procedure another 5 times, and so on and so forth. So we only want our program to run for 5 times, so therefore we're going to use this onStart. Now it's good practice to take any blocks that you're not using, and let's go ahead and drop them back into our trash bin or back into one of your drawers. Now that we've gotten rid of that, we can go ahead and take a look at how we want to start programming this. So we have an onStart. The next thing we want to look at is we want something to repeat 5 times. Well, when we're using something to repeat, what we really want to have happen is we want that actual command to loop whatever is inside of it. So if we look at our MakeCode, we have this loop drawer. And we open that loop drawer up, you have this repeat for 4 times. So we're going to go ahead and take that block and drop it into our onStart. Now here we have a repeating for 4 times, but our flowchart's telling us we want that to be 5. So we're going to go ahead and select the 4 and change the 4 to a 5. Now whatever we put inside of that block or in that do command, that is going to go ahead and repeat for 5 times before ending. The next thing we want to look at is our first command within that loop, and that's to go ahead and show our first initial. Now there's a couple different ways that we can go ahead and do this. One way of doing this is under the basic drawer. You can actually go ahead and bring in this show LED, and from there you can go ahead and basically outline what your initial would be. So if you wanted to go ahead, we can go ahead and make the letter R. That would be one way that we can go ahead and do that. We can drop that in there. You can see what that kind of looks like. So that will pop up on the emulator, and we're going to see the letter R. Now, anytime you're using text, the easiest way to enter that text is really to go under that basic drawer and use this show string. So this show string is meant for you to go ahead and add text within that block. So again, if we go to that show string and we just simply type in the letter R and drop that into our repeat command, we should see the same outcome. So now we have the letter R showing up on our screen. Either way is fine to do. Some ways are just a little bit easier than others. I'm going to go ahead and stick with this show string. So I'm going to go ahead and take that show LEDs and drop it back into our actual drawer. Now what we're going to notice on the emulator is that when the program initializes, it's repeating to show that string R 5 times. We're not actually turning the letters off or your LEDs off. So what we need to do is we need to tell this show string R how long it needs to stay on for. And in order to do that, that's where that pause for 500 milliseconds is going to come in. So we can go to our basic drawer, and under our basic drawer, we can take a look and we see all these commands. All the way down at the bottom, you're going to have this pause for milliseconds. We're going to go ahead and bring that in and make sure it goes into my repeat loop. From here, we're going to go ahead and hit that drop down, and we're going to change that to 500 milliseconds. So again, if we take a look at our emulator, you're going to see that the letter R is going to show for 500 milliseconds. It's going to show again for 500 milliseconds, and so on and so forth. What we haven't done at this point is actually turn the LEDs off. Now again, there's multiple ways that you can go ahead and do this. One way is to just simply to go to the basic screen, and we can go ahead and grab this show LEDs, and we can leave all of those LEDs blank. And if we go ahead and drop that underneath the pause, what you should see is that that letter R is going to turn on. Half a second, it turns off and blinks back on. Now we're going to go ahead and pull that block out of there because there is a much easier way to do that. Instead of using that show LEDs, we can go under our basic. And if you look in here, we're going to see that we have a clear screen. So that's going to clear whatever is on that LED panel. So we're going to go ahead and drop that clear screen in, and we can get rid of our show LEDs. Now we have our on start. We're going to repeat 5 times. We're going to show the letter R for a half a second. We're going to clear the screen. And then what's going to happen is we're going to show that letter R again. So what's really happening is that when we clear this screen, it's showing the letter R almost immediately, and we're not able to see it happen. And the reason for that is because we haven't added that second pause. We haven't told it how long do we want the screen to be cleared for. So we can go ahead and add another pause block, and we can do that by going to our basic drawer and grabbing our pause block. Or you can also go right from in your emulator here and simply right click on pause and select duplicate. That will duplicate any of the code that you have. Now that we have that second pause for 500 milliseconds, we can drop that in, and let's take a look at what is going to happen on our emulator. So what you should see is that that letter R should blink for 5 times, and after 5 times, it's going to clear the screen and it should remain off. So that's just one way that you can go ahead and program your blink.
I try to hide them. Sometimes it feels like I'm defined by them. All of the evidence stacked against me, all of the fingers pointed at me. I can't deny it, all of my mistakes woven through my story. All the mess I make, God, use it for your glory. Every wrong turn is true, let me right here to you. I may lose my way, nothing's greater than your grace. Not even my mistake, not even my mistake. to be holy, but I still wrestle with the old me. You know who I am and who I'm becoming, through all the dirt and the stains that love me. I can't deny it, all of my mistakes woven through my story. All the mess I make, God, use it for your glory. Every wrong turn is true, let me right here to you. I may lose my way, nothing's greater than your grace. Not even my mistake. Na na na, na na na. Not even my mistake. Na na na, na 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 na. Every hard fall, back in yesterday. Every stumble that I've yet to make. Oh, the cross redeems and washes them away. Woo, washes them away.
All right, nestlings. So let's go ye therefore and be nerdy and be super awesome. As always, I will catch you on the flip side, and peace out.
Let me right here to you. I may lose my way, nothing's greater than your grace. All of my mistakes woven through my story. All the mess I make, God, use it for your glory. Every wrong turn is true, let me right here to you. I may lose my way, nothing's greater than your grace. Not even my mistakes, not even my mistakes. No, not even my mistakes.